For this one, it asked me to do f of g of 2. This is my composition. So essentially what I'm doing is I'm doing substitution twice. I'm plugging the 2 into the g function, and then I'm plugging whatever that is into the f function. Okay? So I'm doing f of g of 2. So when I do g of 2, I'm plugging the 2 into the g function. That's going to be 2 squared minus 5, which is 4 minus 5, which is a negative 1. So now what I'm doing is f of negative 1, which means I want to take the negative 1 and plug it into the f function. And when I do that, it gives me a positive 1. And that's it. All right? Doing the same thing with the next one. I'm plugging it into the f function first this time. So I'm doing f of negative 4, which means I'm doing negative 4 plus 2, which is a negative 2. So what I have is g of negative 2. So I'm plugging the negative 2 into the g function, which is a 4 minus 5, which is a negative 1. And the next one is telling me to do f of 3. So I'm plugging the 3 into the f function, then I'm plugging whatever that is into the f function again. So I'm doing f of 3, which is telling me to do 3 plus 2, which is 5. So now what I have is f of 5. So I'm going to plug that 5 into the f function, which gives me a 7. And that's it. It's just substitution multiple times. If I look at something like this guy, I'm given a set of ordered pairs, and I want to find f to the negative 1 of x, which is really my way of saying the inverse of f of x. Remember, the inverse, we just do the exact same thing, except we switch the ordered pairs. Instead of negative 4, 1, we do 1, negative 4. Instead of 0, 2, I do 2, 0. Instead of negative 1, 5, I do 5, negative 1. And that's it. That's my inverse. I do the same thing with my g function. I just switch each of the ordered pairs. So I start with the first one. Instead of 3, 3, I do 3, 3. I switch them. Instead of negative 1, 1, I do 1, negative 1. Instead of 6, 0, I do 0, 6. And that's it. That's my inverse. Okay, I switch the x and the y's. Number 44, I want to find the inverse. And algebraically, when I don't have ordered pairs, I'm still going to switch the x and y, except this time I've got y equals a 2/5 x plus 3. So I'm literally going to switch the x and the y. I'm going to do x equals 2/5 y plus 3. And I'm going to solve it for y, just because I typically write equations solved for y. So I subtract the 3. It's x minus 3 equals a 2/5 y. You could multiply each side by 5 here to get rid of the fraction. When I do that, that's going to give me a 5x minus 15 equals 2y. And now I divide each side by 2. And really, you could leave this as one big giant fraction. I'm going to split it up and write it as 5 halves x minus 15 halves. Just because now it's in slope-intercept form, I'm going to put it back in my function notation. And that's it. This one, it's asking us, are these inverse functions of one another? And the easiest way to do this is to do our composition test. And if we do the composition test here, we're looking to get an x each time. So if I want to get an x each time, I'm just going to do my composition test and do f of g of x. And then if I get an x there, I'll do g of f of x. All right? And you have to get just an x each time. Nothing else will do. So when I do this, I'm going to plug this in. That's the square root of x minus 5. But instead of x, I'm plugging in my g of x function, which is the x squared plus 10x plus 25. And I clearly didn't give myself enough space here. And now I want to simplify this thing. And keep in mind that the square root, the x squared plus 10x plus 25 is the same thing as x plus 5 squared, if I factor that thing. And now when I take the square root of this guy, the square root of this thing technically is the absolute value of x plus 5, which means this is going to be a plus or minus x plus 5, which means I get two separate things here. When I treat it as the positive version of this thing, I end up with just an x. When I treat it as the negative version of this thing, I end up with a negative x minus 5. So I end up with a negative x and a minus 10 here. And really, that just doesn't work. Okay? Because of that plus or minus right here, this thing is not going to be inverses. If there was a plus or minus in front of this thing, then it would be okay because the plus or minus would cancel out with the other plus or minus, and then it would be fine. So since I did not get just an x here, I can safely say, no, these are not inverses without even bothering to do the g of f of x, without even bothering with the second half of this composition test. Okay? For this one, it says find each value in graph. I want to find the vertex. To find the vertex, I do the opposite of b over 2a. So that's a 2 over 2 times 1, which is a 2 over 2, which is 1. That's the x value for my vertex. And then I plug it back in to get the y value for my vertex, which is going to give me a -1 minus 8, which is a -9. The axis of symmetry is x equals the x value from the vertex. The y-intercept, I plug a 0 in for x. And if I plug zeros in here, so it's going to leave me with this guy, the -8. For the x-intercepts, we have to plug a 0 in for y. So essentially what we're doing is x squared minus 2x minus 8 equals 0. And I can solve that by factoring. That's an x minus 4 and an x plus 2. So I find out that x equals 4 and x equals a -2. And really, that's just two separate order pairs. It's the 4, 0, and then a -2, 0. And for this one, since the a value is positive, the number that's out front is positive, means this parabola is going to open up, which means I'm going to have a minimum value. So now I just start to graph these things, and I'm going to scale this graph by 2's here. So 2, 4, 6, 8, -2, -4. Just because that -9 is not going to fit on here very nicely. So I do the 1, -9. It's right here. Oh, sorry, 1, -9. 1, -9 is right here. X equals 1. Axis of symmetry is this vertical dotted line. Y equals a -8. For my y-intercept, I can reflect that point over here. 4 and a -2 for my x-intercepts, and that's enough information to graph this thing. I get a nice looking parabola that looks like this, and that's it. Okay? Number 47, I want to graph this thing, and this is essentially in vertex form. There's my h and my k, so the vertex is 1, 3. So I plot 1, 3 is right here. I know that this is going to open down because the a value is negative, and it's going to be stretched vertically, so instead of going down 1 over 1, I go down 2 over 1. And I'm going to draw a V here because that's what the absolute value is always going to look like. It's just a nice V shape. And that's it. From this one, absolute value, again, the vertex this time is a -2, -4. Which is right here. And this one's going to open up because my a value is a +1 and have my standard width, which is up 1 over 1. So I draw a V that looks like this. And that's it. For this one, the square root, remember, this is going to give me a sideways parabola, and depending on whether I have the positive version or the negative version, it gives me half a sideways parabola. But again, think of it this way as the vertex of being -3, 1. So -3, 1 is right here. I know it's going to open up because of the a value being positive. It's going to be stretched vertically. So instead of having my typical shape, it's going to be stretched just a bit. Look like this. It's half of the sideways parabola because I only have the positive version. And then this last one, the piecewise function. Basically, the piecewise function breaks the graph into these pieces. So x being less than a -3 is the piece that's over here to the left of this green dotted line. X being between -3 and +2 is stuff between the two dotted lines. And then x being greater than or equal to the 2 is the stuff to the right of the dotted line. And then I'm just going to graph a different function on each of these pieces. In this first piece over here, I'm going to graph this first function, y equals a -4. And y equals -4 is the equation of a horizontal line. It's this horizontal line right here. But what I do is I only graph it in the specified region. I only graph it in this first section. So I don't graph any of these pieces of it just in this first section. When I actually get to this line, I use an open dot because there's no equal to condition over here with my x is less than -3. Looking at the next section, this middle section right here, I'm going to graph this function, the 2x minus 1, which has a y-intercept of -1 and a slope of 2. And again, I'm only going to graph it in this section, so instead of graphing the whole thing and then having to erase pieces, I'm just going to graph the pieces in this section. On that first, over at -3, I'm going to use a closed dot because there's an equal to condition. Over here, I'm going to use an open dot because there's no equal to condition. And then the last piece of this thing, I'm going to graph the y equals a -x plus 2, so that has a y-intercept. And again, it's a y-intercept of 2 and a slope of -1, which would look like this. But I don't want to graph this whole thing. I only want to graph the piece that's over here. So I get rid of the pieces that aren't over here. I get rid of the stuff that's over on this side of that dotted line. So when I get a piecewise function, I use a closed dot here because there's an equal to condition. But a piecewise function, we get a graph that's in pieces. I have a little piece of one function, a little piece of another function, a little piece of another function. And that's it. I hope this was helpful, and good luck on your midterm.
Hello? Testing. Okay, I'm ready. Hey guys, it's Emily Hamburger speaking. Mr. Jansen knows math. Resume.